Hello everyone, myself Dr. Santami Kundu. I welcome you all to this lecture of soft computing techniques. This is the third lecture of module 10. So in module 10, we have discussed Rack membership functions, dependency of attributes, Reduct and core. So here today also we'll discuss the Reduct and core etc. So some issues in decision table. Some of the attributes may be not required. Their removal cannot worsen the classifications. The concept of dispensable, which is not required or superfluous, and dispensable attribute. The attribute A is dispensable if indissimilarity relations of R is equal to the indissimilarity relations of R minus that attribute. So that is attribute A. So otherwise, if these two are equal, not equal, I mean if indissimilarity relations of R is not equal indissimilarity relation of R minus A, then A is dispensable. So last class we have discussed that let S, that is set of objects and conditional attributes with decision attributes, may be a decision table. Let A be an attribute in C. The attribute A is dispensable in S if positive region of U by D with respect to C is equal to the positive region of U by D with respect to C minus A. If these two are not equal, then A is indispensable. So A is indispensable if these two are not equal. Positive region of U by D with respect to C is not equal to the positive region of U by D with respect to C minus A. If these two are not equal, then A is indispensable. If equal, then A is dispensable. So the family R is independent if each attributes of R is indispensable in R. Otherwise, R is dependent. And core of R is equal to the intersection of all reducts. So reduct, the REDR is family of all reducts. So reduction of attributes. In this class, we investigate one of the natural aspects of reducing data which concern identified equivalence classes, that is objects that are indiscernible using the available attributes. In order to make some savings, only one element of equivalence class is needed to represent the entire class. The other aspects in data reducing is to keep only those attributes that preserve the indissimilarity relations and consequently set approximations. The rejected attributes are not required since the removal cannot worsen the classifications. In order to express the above idea more precisely, we need some auxiliary notation. Let S equal to set of attributes and object be an information system. B is a subset of it. Let some value A belongs to B. We say that A is dispensable in B if indissimilarity relations of B is equal to indissimilarity relation of B minus A. Otherwise, A is indispensable. If these two are equal, then it is dispensable. If not equal, then it is indispensable. A set B is called independent if all its attributes are indispensable. Any subset B1 of B is called reduct of B if B1 is independent, and you can write that independent relation of B1 is equal to independent relation of B. Hence, a reduct is a set of attributes that preserve partitions. It means that a reduct is the minimal subset of attributes that enables the same classifications of elements of the universe as the whole set of attributes. In other words, attributes that do not belong to a reduct are superfluous with regard to classification of elements of the universe. There is usually several such subsets of attributes, and those which are minimal are called reducts. Computing equivalence class is straightforward. Finding a minimal reduct, that is a reduct with a minimum number of attributes among all reducts, is NP hard problem, that is non-polynomial hard problem. It is easy to that the number of reducts of an information system with m attributes may be equal to the combination of m and m by 2. So you can write it m by 2 or m by 2, that is the floor function. M by 2 is a floor function. Now try to understand these concepts. So in rough set theory, the reduct and core are concepts used to simplify and analyze data by focusing on essential attributes. Reduct, a reduct of a decision system, that is set of attributes in a data set, is a minimal subset of attributes that preserve the classifications or decision making ability of the original set of attributes. In simpler terms, the reduct is a subset of features that can still distinguish objects or classify them the same way as the full set of features. The reduct helps in feature selection by reducing dimensionality while maintaining the same decision making power. Key properties of a reduct. A reduct is a minimal set that and it is the smallest set of attributes that still retains the ability to discern decisions or classifications. If any attribute is removed from the reduct, it would no longer preserve the classification's power of the original set of attributes. Now the concept of core. The core is the set of attributes that are essential for the classifications in the decision system. In other words, the core is the set of attributes that cannot be removed without affecting the ability to differentiate between objects. Key properties of the core. The core is a set of attributes that are not required. Every reduct includes the core. The core attributes play a crucial role in a decision making, and removing them would disrupt the classification ability. Relation between reduct and core. Reduct is about finding minimal subset of attributes that retain classification power. Core identifies the attributes that are indispensable for classifications. In practice, the core is a subset of every reduct, meaning that the core consists of attributes that must appear in all minimal subsets of the attributes. We have discussed that core is the intersection of all reducts. Example, if a dataset contains attributes, that is A1, A2, A3, A4 with the decision functions, the reduct would be A1 or A3. If these two attributes can still distinguish the object effectively, the core might be A1. If removing A1 would lose the ability to distinguish between objects, meaning A1 is necessary in any reduct. Summary, the reduct, a minimal subset of attributes that preserve classification, core, the essential attributes that cannot be removed without losing classification power. So now try to understand one example. So consider an information table. Their attributes are P, Q, R. Table is R of three equivalence relations of P, Q, R with the following equivalence classes. So here indisputable relation of P, that is U by P, that is x1, x4, x5 is having same number, x28 also the same number, x3 different, and these two are same number. So from this here we have understood that there are 8 objects. So the objects are x1, x2, x3, x4, x5, x6, x7, x8. So here x1, x4, x5 are the same number. So x1 is 1, x4 is 1, x5 is 1. x2, x8 has the same number. So x2, 2, x8, 2. x3 is different number 3, and x6 and x7 are the same number, that is 4, 4. Now for the q, so here x1, x3, x5 are the same number, so 4 is there. So x1 is 5, then x3 is also 5, and x5 is also 5. Then s6 is 6, s6 is 6, x2, x4. So x2 is 7, x4 is 7, x7 is 7, x8 is also 7. So if I write the value of r, for r is that, so 8, 7 is that, so x5 and x1 and x5. So x1 is 8, x5 is also 8. Then x6 is 9. Then x2 is 10, x7 is 10, and x8 is also 10. Then x3 is 11, x4 is also 11. So in this way we can make the table. So table is that x is as I said, interpretation of P is x1, x4, x5, x2, x8, x3, x5, x6, x7. So in this way, from the table, I hope you have understood this here. So same table is there. So check for indispensable. So for A, if indivisibility of R is not equal to indivisibility relation of R minus A, then you can say A is indispensable. Otherwise, if these two are equal, if indivisibility relation of R is equal to indivisibility relations of R minus A, then A is dispensable. So we need to check these things. So before that, we try to find the indivisibility relations of R, the whole set. So indivisibility relation of R, that is U by R for the whole set. So now see here, 158, 158. So x1, x5. Now x2, 2710 to x2, x8. 2710, x2 and x8. Now x3, 3511, no one is 3511. 1711, no one is 1711. And x646, and another one is that x7. So these are the independent relation of R. So we have calculated the independent relation of R, x1, x5. Now independent relation of R minus P. So if we remove the P from R, we'll get R minus P. So remove the P. So here we'll get x1, x5, then x2, x7, x8. So x6 is different. So you can write here. So indivisibility relation of total R minus P. So here you can check that indivisibility relation of R minus P. So remove the P. 5, 8, 5, 8. So it is x1, x5. Then 7, 10, 7, 10. So it is x2, x7, x8. Then 5, 11, 7, 11, 5, 8 different. Then you can write it x3 is different. Then you can write is that x4 is different and x6 is different. So see, these two are not equal, so we can say P is indispensable. So discuss it. So that is indivisibility relation of R minus P. Similarly, you can find indivisibility relation of R minus Q. It is x1, x5, x2, x8, x3 and these things. So indivisibility relation of R minus small r, also the same thing. So here you can check that indivisibility relation of R is not equal to indivisibility relation of R minus P. See, these two are not equal. So P is indispensable. As indivisibility relation of R is equal to indivisibility relations of R minus Q, and this is also equal to indivisibility relation of R minus small r. See, these two are equal, so Q and R are dispensable. So this is the concept of indispensable and dispensable. I hope you've understood these things. So now check it. So P is indispensable, Q and R are dispensable, as these two are equal. So in Reduct 1 we can consider P and Q, and Reduct 2 we can consider P and R. So core will be the intersection of all Reduct. So here core is the intersection of these two, that is P. So I have you understood the Reduct and core. So similarly, we are going to consider another example. So this is also a decision table. So patient objects are patients, that is P1, P2, P3, P4, P5, P6. Headache for P1 is no, muscle pain is yes, temperature is high, flu is yes, P2 headache is yes, muscle pain is no, temperature is high, flu is yes. For P3 headache is yes, muscle pain is yes, temperature very high, flu is yes. For P4 headache is no, muscle pain is yes, temperature is normal, flu is no. For P5 yes, no, high, no. For P6 headache is no, muscle pain yes, temperature is very high. So try to find the indiscriminate relations of R, that is headache, temperature, muscle pain, and then C minus of that. So first to consider, let C equal to, so here I am writing it, let C equal to the headache, muscle pain, temperature. So find indiscriminate relations of C. So here no ESI. So no ESI is not, no, here is no ESI. So it is P1. Now yes no high, yes no high. So P2 P5. Then yes very high. So P3 is different. P4 no yes normal. P4 is different. And no yes very high. P6 is different. So similarly, you find independent relation of C minus muscle pain. So if you see C minus muscle pain, or drop the muscle pain here, so it is no high, so nobody is no high, so P1, P2, P5, so yes high, yes high, P2, P5, and P3, P4, P6 are different. So these two are equal. So you can say that muscle pain is dispensable. Similarly, if you find that C minus headache, so you remove the headache here. So yes high, so P1 is different. No high, P2, P5. P3 is yes very high, P6 yes very high, and P4 is different. So these two are not equal. So you can say the headache is indispensable. So we discuss it here. So here I am saying that these two are not equal. So headache is indispensable because these two are not equal. P3, P6 is there, so it is not equal. So this is indispensable. For this example, here in this situation C minus muscle pain equal to the C. So C, these two are same. So muscle pain is dispensable. We'll solve these questions. Muscle pain is dispensable. We'll solve these things in the later slide. So this is the brief idea. So now try to understand the next concepts. So here that we consider C equal to temperature, headache, muscle pain. There you have seen the indiscriminate relation, that is INDC is P1, P2, P5, P3, P4, P6. Discriminate relation C minus headache is P1, P2, P5, P3, P6, P4. These two are not equal. So as I said that headache is indispensable. Now indiscriminate relation C minus muscle pain is P1, P2, P5, P3, P4, P6. So these two are equal. So muscle pain is dispensable. Now try to understand the independent relation of C minus temperature. So C minus temperature. So we remove the temperature. So if you remove the temperature, then you will see that no yes. So P1, P4, P6, P2, P5, and P3 is different. So here this is the C minus temperature. Again, these two are not equal. So you can say temperature is indispensable. So with this example, I hope you have understood the concept of indispensable and dispensable, etc. So now conclusion. So I hope in this class we have understood the concept of indispensable and dispensable. We also understood the concept of reducts and core, where core is equal to the intersection of all reducts. So the question for today's class is that you can assume any decision table and find indispensable or dispensable attributes, reduct and core. So these are the references of today's class. Thank you.